Hey everyone, so today we're going to be comparing the key features of different functions. So basically all this means is you're going to look at two different functions or the graphs of two different functions, see what they have in common, see what's different, or if they give you a question like which of the following two graphs both have the same vertical asymptote, like you'll be able to decipher which answer is correct. All right, so the first example we have is our first function is 2 to the power of x. And our second function is the square root of x minus 2. So this one is our basic parent function of 2 to the power of x. There's no up or down movement. There's no right or left movement. So this one, our square root function, has been moved 2 to the right, because remember, if it's with the x, it's opposite of what you see, but it hasn't been moved up or down. So here are the graphs of our two functions. Okay, our f of x is just 2 to the power of x, and then our square root function that's been moved 2 to the right. All right, so let's look at the different key features and what they have in common or what is not in common. All right, so our domain, the domain of our f of x, it goes to negative infinity on our x, and it ends in an arrow, so it's going to go positive infinity on our x, so all real numbers. Our range, so we remember with the exponential, we do have a horizontal asymptote at y equals 0, unless it's been moved up or down. So let's go ahead and fill that in. Y equals 0. Does it have any vertical asymptotes? No. So let's go back to range. So since it goes to 0, right, starts at 0, but it never touches, so the parenthesis, and it goes to positive infinity. Okay, do we have an x-intercept? No, because we've got the horizontal asymptote. And the y-intercept, unless it's been moved up, down, right, or left, it's always going to be 0, 1. Okay, where is this graph positive? Meaning, where is this graph above the x-axis? Because in order for it to be a positive graph, the y value of all the points are positive, okay? So since it never crosses the x-axis, it's always positive. So the domain where this graph is positive, all real numbers. The domain where it's negative is nothing because it never goes under the x-axis. Increasing or decreasing. Now again, we're going from the left side of the domain to the right side of the domain, and we're seeing what the y values do. Are they increasing or are they decreasing? So for this one, they're constantly increasing across the domain. So the domain where it's increasing is all real numbers again, and it never decreases. So now what's our end behavior? So as x goes to negative infinity, the y values get closer and closer to 0. So f of x goes to 0. Okay, as x goes to positive infinity, what do those y values do? Okay, as it goes to positive infinity, the y values go to positive infinity. All right, so now let's do that for the g function. Okay, our domain. Well, it starts at 2 and goes to infinity. Our range, the y value starts at 0 and goes to positive infinity. Does it have a vertical asymptote? No, and no horizontal asymptote. Right? Does it have an x-intercept? Yep, at 2, 0, but it never crosses the y-axis. Okay, where on the domain is this graph positive? Well, it's positive on the domain from 2 on, so 2 to positive infinity. And is it ever negative? No. Increasing, so it increases from 2 on, and it is never decreasing either. Okay, what about our end behavior? So as x goes to positive, it should be negative infinity, but since the lowest value on our domain is 2, we're going to start there. So as x goes to 2, g of x goes to 0, right? Now as x goes to positive infinity, g of x goes to positive infinity as well. All right, now, what do they have in common? Well, they have the domain of 2 to positive infinity in common. Okay, and what do they have in common with their range? That'll be parentheses 0 to positive infinity, because remember, it doesn't exist at 0 here. No vertical asymptotes. And since this one has the horizontal and this one does not, there's nothing in common on the horizontal asymptotes. Okay, nothing in common on the y-intercepts or the x-intercept. Where are they both positive? Well, since this is positive through the entire domain and this is only positive from 2 to positive infinity, they are both positive from 2 to positive infinity. And since they are both never negative, we'll just put never negative. Okay, where are they both increasing? Again, 2 to positive infinity. Are they ever decreasing? Never decreasing. Okay, and what in behavior do they have in common? Well, as x goes to negative infinity and x goes to 2, so that is not the same. But here we have the same in behavior as x goes to positive infinity, that the y values, or the f of x, g of x, both go to positive infinity. Okay, this is our next example, and this one we're going to use more of what we learned last chapter, all right? So first we have f of x, and I'm going to put this f of x in green so you can see it a little bit better on our graph down here. And we also have g of x, okay? So the first thing we do with the f of x function is we need to factor. So we'll factor the 2 out. So that leaves us with x squared plus 4x plus 3. Okay, what are factors of 3 that add to 4? That'll be 3 and 1. So then we know our factors are x plus 3 and x plus 1. So I'll just erase for sake of space. So we have x plus 3 and x plus 1. And the denominator, since it's our special case, it's x plus 1, x minus 1. And our special case meaning it's called difference of squares. So first thing first, let's see if anything cancels on our rational, which, as you can see, it does. So remember, we have a whole at x equals -1, okay? And over here in the domain, that's where that'll come into play, okay? All right, so let's go ahead and graph these. Okay, so if you notice, our f of x is this one, and our g of x is here, okay? Now, one thing I want you to notice that is very pertinent to the graph of f of x is that we have a hole here at x equals -1, okay? Even though g of x does connect at this point, it is a hole on our f of x function. Now, the next thing we need to talk about is solutions of 2 different graphs, or they also call solution of the system of these functions, okay? The solution just means where these 2 graphs intersect, okay? That's all it means. So here, our solutions are 210 and -3, 0. Now you can find solutions a bunch of different ways, all right? You can use elimination, and we'll actually get into this more deeply in the next video, but you can use elimination, you can use substitution, you can even go back and use matrices if you really like that. You can also use your graphing calculator and just ask it to find the intersection, okay? But we'll get more into that in the next video. So right now, all we need to know is the solutions are 210, -3, 0. It would be -1, -2 if this wasn't a hole, okay? All right, so what is our domain of f of x? Okay, it goes from -infinity to, right, the whole, -1, union -1 to our vertical asymptote of 1, because remember, our vertical asymptote are the zeros of the denominator. So let's write that in. Okay, and also let's go ahead and look at our horizontal asymptote. So since the powers of the numerator and the denominator are equal, we divide the leading coefficients. So our horizontal asymptote is just 2. So y equals 2. Okay, so this goes from -1 to our vertical asymptote of 1, and then it goes from 1 to positive infinity. Well, okay, now let's look at the range. So -infinity, okay, and then we have that whole, so it goes to -2. Union, -2, okay, our horizontal asymptote of 2. Union, 2 to positive infinity. Okay, x-intercept. So it crosses the x-axis at -3, 0. And then our y-intercept, when we graph it on our calculator, I can use the trace function and find that our y-intercept is 0, -6. All right, so where is this graph positive? So it starts off being positive, so from -infinity to -3, and then it goes positive again here. So union, our vertical asymptote of 1 to positive infinity. Okay, where is it negative? Okay, it's below the x-axis here. So from -3 to our vertical asymptote of 1. Where is it increasing? So here we know the y values are decreasing here, and they start high and they decrease here. So it's never increasing. Where is it decreasing? We just stated everywhere it is decreasing. So our domain of where it is decreasing is -infinity to -1, union, -1, 1, union, 1, positive infinity. So just copy the domain since it's constantly decreasing. All right, and behavior. X goes to -infinity. F of x goes to our horizontal asymptote of 2. Okay, and as x goes to positive infinity, f of x still goes to our horizontal asymptote of 2. Okay, all right, so now let's look at the g function. Okay, our domain, okay, goes to -infinity and goes to positive infinity, so all real numbers. Our range, so when we put this in the calculator, we find that our vertex has a y value of -2.2. So this goes from -2.25, sorry, 2.25 to positive infinity, okay? Vertical asymptote, none. Horizontal asymptote, none. X-intercept, so we definitely have one at -3, 0, and we also have one at 0, 0. Y-intercept, 0, 0. Okay, where is this graph positive? Above the x-axis. So it's going to be above the x-axis on either side of the x-intercepts. So -infinity to -3, union, 0 to positive infinity. Where is it negative? Below the x-axis. So between our two x-intercepts, so -3 to 0. Where's our function increasing? Okay, so it's decreasing here, it turns here, and then it increases again. Okay, I forgot to write down what the x value is of our vertex, so we'll just go ahead and redo that real quick. So f min, because it's a minimum value vertex. Left bound, yes. Right bound, let's just say 0. And guess. Okay, so -1.5. Let's write that here. This is -1.5, -2.25 is our vertex. All right, so it is increasing from our vertex to the right. So that would be negative 1.5 to positive infinity. And it's decreasing from negative infinity to our vertex. So negative infinity to negative 1.5. In behavior, as x goes to positive infinity, g of x goes to positive infinity. As x goes to positive infinity, g of x goes to positive infinity. All right, what do they have in common? Okay, across the domain that they have in common is the domain of f of x. So instead of rewriting all that, I'm just going to put domain of f of x. Okay, and what about our range? Okay, so the range that they have in common is from this point on minus the whole and the horizontal asymptote. So it's going to be negative 2.25 to the whole of negative 1. No, y value, negative 2. Union, negative 2 to the horizontal asymptote of 2. Union 2 to positive infinity. Right? Well, there's nothing in common here, nothing in common there. They do have the same x-intercept of 3, 0. Not here. And let's see, they are both positive in different points. So definitely they're both positive from here to the left. So negative infinity to negative 3, and we can check that here, right? And then they're actually both positive from the vertical asymptote to the right, okay? So if we look here, yes, so union 1 to positive infinity. Now, what interval on the domain are they both negative? Okay, that'll be negative 3 to 0, and we can check it here. So negative 3 to 0, because that's when the g of x function turns positive. So they're both negative in this interval on the domain. All right, where are they both increasing? Well, since f of x never increases, don't have anything in common there. And where are they both decreasing? Okay, so negative infinity to negative 1.5. And if we look back at the graph, we'll see negative infinity to negative 1.5, because that comes before the whole, but that's where the vertex is, where it changes from decreasing to increasing. Okay, and what in behavior do they have in common? Nothing. All right. Sorry, I did want to say one additional thing. You may not have to put all of these on your paper, okay? Just look at the question you're being asked and see what they have in common, or if they're asking what's different, you know, focus on that. I just wanted you guys to see how you can take two different functions, and especially if you're given an essay question over this, how to do all of these steps for two functions, okay? So if it's just saying which of these two functions have a vertical asymptote of negative 2, okay? You're just going to look at the graph of the answers that they give you and see which one, both of them have a vertical asymptote at negative 2, okay? And that is it. If you have any questions, just let me know. Also email me if you don't feel comfortable putting it in the comments, and I'll see you guys soon.